January 2019, question number 7. It says, a sequence of figures is made from joining polygons with one side with sides of unit length. The first three figures in the sequence are shown below. Alright, we're asked to A, draw figure 4 of the sequence. Alright, so this is a simple enough sequence to draw. So figure 4 of the sequence could possibly look something like this. Alright, so this would be figure 4. So figure 4 of the sequence could look something like that. I guess you could make it neater by using a ruler instead of doing it freehand, but essentially figure 4 of the sequence would look something like that. Alright, the B part of the question. The B part of the question says, study the patterns of numbers in each row of the table below. Each row relates to one of the figures in the sequence. Some of the rows have not been included in the table. Complete the rows numbered I, and triple I. Alright, so let's have a look at the table. Alright, so first of all, we're to study the pattern of numbers. Alright, we notice here we have what? Figure number 1, 2, and 3. And then where it says number of outer lines of unit length, the first digit is consistent with the figure number, so 1, 2, and 3. The second digit seems always to be a 2, and the third digit is the figure number multiplied by 2. Alright, and the parameter seems at all times to be increasing by 3. So let's complete I. The figure number is I is figure 6. So the first digit is 6, plus the second digit is always 2, and the third digit is the figure number multiplied by 2. So this is 6 times 2, which is 12. So the value here is 20. All right. We have we don't know what the figure number is, so let's call it x. Let's call here x. We don't know what it is. So in here it would be x plus 2 plus 2 times x, which is 2x, and this is equal to 65. So let's do some calculation. We have x plus 2 plus 2x is equal to 65. So therefore 3x plus 2 is equal to 65. So 3x is equal to 65 minus 2. 3x is equal to 63. Divide both sides by 3. So the figure number x is actually equal to 21. Alright, so the number here is 21. And then inside here we're going to have 21 plus 2 plus 2 times 21, which is 42. Alright, so we're able to complete that line. Alright, and the final line we're gonna have what? The first digit here is always the figure number, which is n, plus the second digit is always 2, and the last one is what? 2 times n. So now n plus 2n is 3n. So over here we have 3n plus 2. All right, let's go further. Next, we're to show that no figure can have a perimeter of 100 units. We're to show that no figure can have a perimeter of 100 units. All right, let us use the third line where we have what? Perimeter. The perimeter is actually 3n plus 2. And let us say, for argument's sake, that this perimeter is equal to 100. All right, now, if the perimeter can be 100, n, which is the figure number, will come out to be a whole number value. All right. So in order for 100 to be a possible perimeter of this what of a figure in the sequence of figures, in order for 100 to be the perimeter of a figure in the sequence of figures, n, the figure number, must come out to be a whole number. If it comes out to be a decimal, then 100 cannot be a perimeter in the sequence of what figure of a figure in the sequence of figures. All right, so we're going to have 3n is equal to 100 minus 2. 3n is equal to 3n is equal to 98. Now divide both sides by 3, and what we get is that n is equal to 3 and remainder no 3, and then into that goes what 2 and 2 over, so it's point what, or just say and 2 over 3. All right, so since n is not a whole number, so I could say since n is not a whole number, 100 units is not a perimeter of a figure in this sequence. All right, so this is the answer for C. Let's see if we can rub out II here. II shouldn't be II, it should actually be C. So this is C. All right, let's see if there is a D part of the question. No, there isn't a D part of the question. So this is the end of the question.